Hello. Here's an IBSL question. Hb1C, hemoglobin 1C, is a long-term measure of a person's risk of being diabetic. The lower the percentage, the lower the risk. In a study, 7 volunteers were taken before and after an intervention program. So that this measurement was taken twice on the same volunteer before and after. Here's the data before, after. So what are we looking for? If we look at the question carefully, this test should lower, does the test lower the percentage or not? And if we call this mu naught, and if we call this mu, we are testing if mu is less than mu naught. This is the average mu. What is the null hypothesis for this test? Now, before we come to that, what test are we going to use? Because we are having the same sample, in this case, our sample is a human being, is the volunteer himself, we can use a paired t-test. If the sample is different, we will have to use two sample t-tests, which we will do in another question. What is the null hypothesis for this test? The null hypothesis is simply that there is no difference. Or H null is the way you write it. H null is pre-intervention minus post-intervention. Or we can say H null or in words, we can put it as there is no difference between the pre and post-intervention groups. Second part of the question, what is the alternate hypothesis? For the alternate hypothesis, the opposite is true. The opposite is true, but we have three options. First option is there is a difference. We don't care whether it's higher or lower. Second option, the pre is higher than the post. Third option, the pre is lower than the post. In our case, what are we interested in is mu is less than mu naught, or you can say is this. The third part of the question, calculate the p-value for this test. Here is where we use the calculator. We go to statistics, stats test, to t-test. We input our data and okay, here's the example. We are the CX Inspire now. I've keyed in this data manually. This is the pre-data, the post-data, and the difference. We go to menu, statistics, statistical test for t-test. We're going to use a t-test. Later we will do another example on two sample t. But for this, we will do a t-test. 2 input, we're using data. What are we comparing with? Mu naught, we are comparing with 0, meaning there's no difference. And our list is in the column I've called difference. Frequency is 1. Alternate hypothesis. Mu is less than mu naught. This is what we are comparing. We want the new intervention to be better than the previous. We want to prove that. And so mu is less than mu naught. We save in column D. Enter. And here we are. Our p-value is 0.035. So finally, we have got a p-value of 0.038, or we can say 3.8%. And what is the conclusion we get from this test? The conclusion for this test is we can reject the null. Why we can reject the null? So 3.8% is less than 10%, and therefore it is significant.